Today we are going to study what it means to create a stem plot with a given set of data. If we look at example 1, we can see all of the amount of caffeine per several soft drinks. What you'll see when you look at the stem plot is a series of stems and leaves. When we look at this, the stem is typically the main digit, such as the tens place, the hundreds place, etc., and the leaves are typically the ones digits. If you look at this data, you'll see that the number 20, for example, is represented by 2 and then a vertical bar and then a 0. And if we look at the number, let's say 47, 47 is represented right here on my stem and leaf plot. The nice thing about a stem and leaf plot is it allows us to take a look at our data and see that it ranges from the 10s to the 40s, and we can quickly put it in order. Now, a stem plot needs to have consistent spacing with your leaves, and the leaves need to be in numerical order. We will also show repeats. When a stem plot is done correctly, it can be thought of as a visual histogram if you turn it on your side. If we look at this, we can see that this is kind of like drawing the curve to my graph. So in that regard, a stem leaf plot can give us the same visual reference that a histogram can. Sometimes we will do what's called split the stems, and when we split the stems, it allows us to have a better view of the distribution. Each stem is listed twice, and we're going to put leaves 0 through 4 on the first one, and 5 through 9 on the second one. When we already have a traditional stem leaf plot above it, it makes it very quick to go ahead and represent it in a split stem plot. For example, there are no numbers with a stem of 10 that has leaves 0 through 4, so this first stem will be left blank. The 5, 5, and 6 from the 1 will be written here. If we look at the line for the 2, all of the numbers that are from 0 to 4 are going to be written on the first stem of 2. So I would see a 0, 3, 3, 3, 4, 4. And then all the numbers after 4, so 5 through 9, would be on the second stem. So we would have 5, 5, 6, 6, 7, 7, 7, 1, 2, 3, 5 8s, and then 2 9s. Pause the video and construct the rest of your split stem leaf plot. The final product should look like this. As we can see, this gives us an even better view of my data. If I were to think of it in terms of an histogram, I can see that the majority of my data is located in that second stem with a 2 as my stem. So from 25 to 29 is where I see the majority of my data. In example 2, this stem plot shows the tuition cost for 81 colleges in Michigan in hundreds of dollars. So what that means is that our lowest leaf, where we see the 1 bar 3, represents 1,300. 1 bar 3 equals 13, and since that's in hundreds of dollars, that's how we get 1,300. Now, notice again how we mentioned that when our stem plot is done nice and neat and spaced correctly, it can serve as a histogram on its side. If we were to draw a curve over this data, we can easily see that this graph has a long tail to the right. So we can say that this graph is skewed right. Without even calculating the median or the mean, we know that our mean will be greater than our median. And again, that's because of this skew right, because we have larger values to the right that are going to pull my mean greater than the true center of my data. Now to find our median tuition, we want to look at how many scores we have. And on this data set, we are told that we have 81 scores. So 81 divided by 2 equals 40.5, which means I'm going to use the 41st data point. So if we go back up to our data set and count for the 41st spot, we can see that the 41st spot is going to occur right here at the 5. And this is my median. That being said, if my median value is 45, then my median tuition is 4,500, because again, this is referring to hundreds of dollars. Now this next question asks if we would expect the mean to be higher, lower, or about the same. And as we already mentioned, we expect it to be higher. And we could say that the mean would be higher because the graph is skewed right. The mean is not resistant, and that's a phrase we're going to use quite a bit. The mean is not resistant to extreme high values. And when we look at our data and compare the low to the high, my low value is $1,300 for tuition, and my high value is $19,000. Very, very big difference. And these couple large values that we see down here at the end, those top 5 values are going to significantly pull the mean up from those lower values that we see that are all in the thousands. Now the next question says, how many schools cost less than $2,000? So in this case, we would add up all of the leaves that we see on the stem for 1. We can see that there are 27 schools that fit this criteria. The next question says, how many schools cost at least $16,000? In this case, we would count all of the schools from leaves 16, 17, or stems 16, 17, 18, and 19, and there are 3 schools in this category. As far as how many schools are between 17,000 and 18,000, since that stem is empty, there are none. And then the range of tuition is the high score, 19,300, minus our low score, 1,300, which gives us $18,000. All right, that's it. Homework is worksheet 4. Have a good day.